Hello everybody. Today I'm going to explain how to solve the problem edge weight assignment from the Codeforces Round 633, which in the Division 1 version it was the problem B, and in the Division 2 version it was the problem D. Basically, we have to find the minimum and the maximum number of distinct integers we can assign to edges from a tree, such that for every pair of two different leaves, the bitwise store of weight of edges on the simple path is equal to 0. I'm going to present a solution based on analyzing the sample test as well as the other tests you may create while thinking at the problem. I'm going to focus on the sample test because the sample tests were actually quite good for this problem and they give you enough details to solve the problem. Let's move on to discussing them. In the first sample case, we can observe that we can actually fill all the edges with a single integer and all the bitwise store values between the values among the paths on the leaves will be always equal to 0. Let's say we are doing it with 1. Since the length of the path between 1 and 2 is 2, and the length of the path from 1 to 6 is 4, and the length of the path from 2 to 6 is 4, we can always fill the edges with 1 for the minimum answer equal to 1. However, for the maximum answer, since we can fill the values on the edges with arbitrarily large integers, we only need to see what edges do we need to assign equal values in order to respect the conditions of the problem. It is quite easy to observe that the only case when we should do this is when for some nodes we have two or more leaf neighbors, like in the case of node 3 here. We can't fill the edge from 1 to 3 and the edge from 3 to 2 with different values because their store will not be equal to 0. So we need to draw from the answer 1. Since there are 5 edges, the answer for maximum will be 4. For the second sample, we can no longer fill all the edges with the same value because the length of the path from 1 to 5 is equal to 3. But after running a brute force or proving this in a mathematic way, you can realize that the answer will be equal to 3 in this case. And this is our minimum answer. For the maximum answer, there are two pairs of leaves which don't respect the condition. This one here with leaves 5 and 6, and this one with leaves 1 and 2. So we need to drop from the answer 2. There are 5 edges, minus 2 is equal to 3. In the third sample, all the paths among the leaves have even length, so the minimum answer will be 1. But there are no pairs of leaves which don't respect the condition for the max. So the answer will be equal to 6 because there are 6 edges. So in conclusion, there are two cases for minimum and maximum answer. For the minimum answer, the answer is either 1 when all the paths from one leaf to another have even length, or 3 otherwise. For maximum number, the answer will be always equal to n minus 1 uh, um, and minus the number of such pairs. Like for example, if we have 3 leaves bordering the same node, like in this case, we are going to drop from the answer 2 because we need to fill them all with the same value, 1, 1, 1. So we need to drop 2 because we will have a distinct number. Also, another thing you should consider when it comes to solving these kind of problems, is that the samples are not this good every time. So you need to create new tests and eventually create a brute force solution like a backtracking approach where you assign values to nodes. The easiest way to assign nodes values to edges or to nodes in case the problem is about nodes is to either assign small values from for the minimum case, or powers of 2 for the maximum case, because the powers of 2 will eventually cancel out in case of bitwise XOR if implemented properly. Now I'm going to explain how to implement this. In order to implement this, we need to use the vector structure from the STL in order to keep the tree. Also, at the beginning, the maximum answer is always equal to n minus 1, and the root will be equal to 1. But we may have to change the root if the node 1 is a leaf. Up now, we are going to run a simple DFS function, which will help us find information about two things. If the node is a leaf, we are going to mark this using an array which tells us if a node is leaf or not. Basically, a node is a leaf if it doesn't have any sun in this new definition of our tree when the root is not a leaf. Also, we need to check out for each node if there is a leaf at a node distance and a leaf at an even distance, because if there are two leaves with distance with different parties, the distance between leaves will always be odd, because even plus even is even, odd plus odd is even, and even plus odd is odd. So we need to check for each node how many of its sons are leaves and whether we have an even or an odd leaf. Or in the case of making the minimum answer equal to 3, we need to have both of them. If you liked watching this video, please subscribe to my channel and also join the Discord server in order to be the first one to get notifications about new videos. Until the next time, stay healthy, stay safe, good luck, and goodbye.